Hey guys, can you hear me?
Yes, we're going live now, Lachlan.
Okay, sure. Hey guys, can you hear me?
Good afternoon,
Yes,
everyone.
we're going live now, Lachlan.
Okay, sure.
Good afternoon, everyone. Welcome to another JD Tan webinar. Today, we have the pleasure of hosting Chuck Stingley, who will be speaking about digitization of enterprise infrastructure, automation, and programmability, and how to get started. Chuck is a 15-year Cisco veteran working as a business development leader, focusing on channel partner strategy within Cisco Learning and Certification. Chuck has basically experience leading partner success at Cisco Devnet, launching the Devnet specialization for partners. Additionally, his background includes Cisco IoT software businesses, helping to launch the Kinetic IoT software platform, and was security and IT focused SEC serving Cisco Global Enterprise account. Chuck is also a CCIE 12175 and a DevNet 500 member. At this time, I would like to present Chuck to you from Cisco, who will be presenting on digitization of enterprise infrastructure, automation, and programmability, how to get started. Chuck, ball's in your court now.
All right, thank you. Thank you, Antoinette, for the introduction. I believe I have resumed sharing here. So I want to say thank you to the audience and thank you for having me. And I look forward to the next hour or so of walking through this topic. As we walk through this topic. So as we mentioned, we're going to talk about the digitization of enterprise infrastructure and leading primarily on the concept of automation and programmability. And really, all three of those things have been a bit of a buzzword or a set of buzzwords in the industry over the last 7 to 10 years as it relates to the digitization efforts and then to automate and to leverage programmability to facilitate that automation, not just at the infrastructure level, but also at the business application level, and then moving into kind of today's world of the application-based economy. How can we make sure that our enterprise infrastructures are put in a place to be able to facilitate those transitions as we move forward into the next generation of IT services? So leading this here, I'm going to come from the concept of what we call Cisco Devnet, and that is that is Cisco's method and mechanism of establishing the concept of programmability to support automation across enterprise infrastructures. And when we built Devnet, we built it on 4 primary pillars: the concept of learning. This was a new concept, so how do we make this engaging to be able to help both our traditional practitioners as well as new entrants to the field, as well as tangentially related. So if I'm a software developer, how do I apply that to infrastructure? And if I'm an infrastructure engineer, how do I leverage software capabilities in order to better do my job? And then that, of course, because it's software, it comes with coding. So the idea of, kind of having both code examples as well as learning capabilities to support that code. And then we feel that this works best as a community. Just so the concept of we've created a community within the Devnet organization. So we have more than 500,000 members globally. That's made up of Cisco internal Cisco customers and our partners, and as well as interested parties within various ecosystems. So there's a lot of members in our community that are in the student population. So for example, if I'm in high school and I'm looking to do something related to computer science or computer engineering, we target and we try to bring individuals from that skill set, from that focus area into the community, as well as at the post-secondary college type of scenario of people that are in computer science degrees or doing some sort of networking or security technologist. we expose them to the concepts of this enterprise automation through our developer community. And by everybody working together, you see some communities on the internet that are very much about, kind of peacocking and, letting me show how better I am than the rest of the community. The way that we've built the Devnet community, we really try to foster that in here, is to make sure that we're always helping and upskilling each other and kind of growing the community for the benefit of the community, as opposed for the individual recognition of a handful of people. And then the fourth pillar that we have here is the idea of actually creating concepts. So it's great to learn, it's great to start to code, it's great to build those connected communities, but what can we actually create with that actually starts to change the world, even at a small level of just making my day-to-day activities and my job simpler, to the idea of engaging enterprise collaboration that reaches out to other areas to help expose and to change the world from that perspective. So again, we're focused on learning, coding, connecting, and creating. And you can find more of that at our developer Devnet portal at developer.cisco.com. One of the things we're trying to do with this, and you may have heard of the term of DevOps, and really what that is that taking a traditional operation mindset that's used in infrastructure, as well as a developer mindset that's used in software programmability, and putting those two things together in the concept of DevOps. And from a dev side, it's all about coding, it's developing, it's about testing. And from an operations side, it's about releasing and deploying and operating and monitoring that. There are skill sets in both of those camps that work very well together, and that kind of defines that DevOps mindset. But really, part of that is it's both. It's importantly to have the culture of there. So instead of having these two silos that I do my thing, you do yours, it's about establishing a culture that shares those best practices, leverages tools to facilitate that, to help teams get up to speed quickly, to understand what's going on, and use a common tool set across those organizational boundaries where and as appropriate, and leveraging automation to get rid of to minimize the effect of the dull, the dirty, the dreary, the boring type of tasks, and to automate those and make sure that we're leveraging communication and collaboration across those. So if I'm a developer and I'm hearing a specific need from a customer, or if I'm from an operations mindset and I know that the facility's power is going to be going through some sort of a maintenance on next Tuesday evening, how do we tie those together to make sure that we have that collaborative mindset, and then making sure that we are transparent across the organization, both from our internal perspective as well as how we communicate to our internal and external customers, and making sure that our IT and operations and the business really understands where we're coming from and what we're delivering, and then what their needs are, so that we can encompass that into the productization of the services that we're creating. As I mentioned, we created the Devnet community, and it's really an ecosystem. So it's not just at the personal level, it's not just at the product level, but it's also at company and organizational levels. So one of the things that we do for the community is kind of leveraging Cisco Plus community for tool sets. So there's API tooling that doesn't come from Cisco, but works well with us and works well with others, that kind of, again, builds that community. And then on top of that, and we'll talk more about things like Postman later, but there are collections that the community will contribute to that says, if I'm trying to do some coding infrastructure on some network switching gear, here's a set of collections that are specific to tasks that you might be creating. And then that, again, helps the community move forward and to do their job quicker, better, and faster, as well as kind of full-blown configuration tools. So instead of doing things at what we would call the element management level, of doing things from one individual piece of equipment to the next, how can we leverage tools that look at that more holistically, that says, irrespective of the type of technology it's covering, and even irrespective of the vendor that manufactured the equipment, how can I leverage this a common configuration tool set to be able to deploy to achieve the outcome that I'm trying to get at, and not just a particular technology stack. And then visualization. Visualization is very important when we're looking at an infrastructure, both from an operational level, but also from an automation level. Automation means I'm doing things faster. So The speed of a good thing is can be increased, but the speed of a bad thing can also be increased. So the idea of visualizing what's happening so I can very quickly see the effect of what I've automated and kind of the day-to-day operations becomes critically important the faster that we affect change, because again, both good and bad propagates at the same speed. So I want to be able to see that as quickly as possible. From the Cisco side, we've also created tools that we've for the community. So we have this concept of what we call Cisco Modeling Labs, which is basically a virtualization of Cisco network infrastructure components. So instead of having to have the physical hardware to try a couple things out, you can actually build a virtual network or a virtual enterprise environment inside of the Cisco Modeling Labs or CML and be able to both test against that as well as program and learn and experiment in that type of environment without having to affect your production environment. And this means that you can also do this in a much more cost-effective mechanisms. We also have things that we call PyATS, and that's an automated test scripting. So it's the idea of automated testing scripts that are written for Python. So as I'm building my programmability, testing becomes very important to that. And we built a framework that helps you to do your testing as you go and your testing as you deploy. And we have documentation for all of the products that we have in here. And I'll go into that more in a little bit detail. But again, it's not just looking at this from a Cisco-centric world. It's looking at this from here's what Cisco's providing, and here's other things that we have from the community and from other vendors, and how we tie that together to build that that community and that ecosystem for leveraging automation and programmability. So with that little bit of a background, I think it's important to understand kind of what to do and where to start and kind of what that looks like. So it's easy to say programmability and automation, but really, what does that mean and kind of where does that come into? And looking at this from kind of a product suite, so you can see up the top, a lot of non-Cisco logos and namings up there as far as whether it's AWS or Google Cloud or Azure, or tying that in with configuration tools like Terraform or service management tools like ServiceNow. All of those tools can be integrated into the ecosystem by leveraging APIs. And you can see down at the bottom, all of the Cisco products, or a subset of the Cisco products, all of those are extensible through API. So that allows us to have kind of open communication, to be proactive in looking at analytics of what's going on with it, as well as to be able to build new services on top of that by creating integrations. So let's say I'm deploying some of my applications or my workloads into multiple cloud locations. I can do that provisioning through APIs and tie that into configuration management and service management tools. But then I can also tie that into things like Cisco WebEx to be able to send messaging and automatically notify individuals if there's a particular outage or a particular anomaly that's going on, being able to tie that in and then tie that back into something like a ServiceNow and create a ticket for that. So I have traceability and accountability for the action and a record of what happened there, but I've automatically notified the requisite teams to be able to troubleshoot and to address that scenario. So kind of giving you a little bit of a background and kind of showing some examples of where that can go, what a journey map looks like here. And I've divided this up into 7 different areas of, starting with learning, then discovering, then coding, then scaling, expanding, deploying, and then automating. So it's not just one thing of where I want to do programmability and automation. For you as an individual practitioner, there is a journey that you go through, or at least a journey of understanding where the components lie in. And from a learning perspective, just kind of going over some basics of what's there. So when I say API is, that stands for Application Programmable Interface. And really what that means is it becomes a standardized mechanism for 2 things to talk amongst themselves. So in the networking, the IT world, there's almost as many standards as there are people in the world. So when we say things are standardized, it gets a little bit, it gets a little odd in that, 2 things that need to talk to each other, they're standardized, but they may not be on the same standard. So the concept of APIs is really meant to become a standardized mechanism or a consistent mechanism for 2 things to talk talk together. And this is really based on the way that that internet web browsing or web traffic is built, with the concept of a client sends a request and the system sends a response back to it. That's exactly the same way that APIs work at least in a RESTful state that we're talking about for enterprise automation, where either a client, which could be you as an administrator, you're going to send a request in the format of an API to a device, and it's going to send a response back to it. Now, that request and response, by calling it a request and response, kind of suggests that it's, I'm always asking and you're always telling. That same message framework, though, can be, instead of a request, I can send a command through that. So what that means is it's not just read only, it can also be read write, meaning that what I call a request, I can actually send a command that tells that end device to actually perform a function or change a configuration. But that same concept lives, that it's, kind of client server of, something says something to the other, and then the other responds back with whatever the information was, or a success code of yes, this was completed, or no, it was not completed, or produce some sort of an error. So again, it's the mechanism it's a standard, consistent mechanism to communicate between multiple devices. On top of those requests, data formats also become important. So again, I may request something, but I could say it in a different language, or I could, dates are a common one, where do I lead with the day, the month, the year, or do I lead with the month, the day, the year? Kind of having that consistent format is important for being able to communicate across devices in a programmatic function. And one of the common methods for that is a data format known as JavaScript object notation, which you may commonly hear referred to as JSON, and that's what I'll refer to through the rest of this. But in JSON, it's the concept of having a nested and structured hierarchy for defining objects, and that's done in both a key and then an attribute pair. And the key is, this is the name of the object, and then the attribute is, this is the attributes of that object. And that can, as I'm showing in the diagram here, you can have those nested inside of each other, so it becomes a mechanism of kind of defining a hierarchy, but consistency across all the objects in the hierarchy. So at the top, I may say tree, and then that's the top level, and then underneath tree I could have pine, oak, elm, maple, whatever that is. And then for each one of those, I can also have additional components inside of there that might be leaves, bark, height, age. But that dictionary would be consistent across all of those, so that I know that if I'm asking you a question about trees, but I really want to understand about pine trees, the same structure of the way the data is stored and the same structure of the way I would ask the question is consistent across the variance of the types of objects that are defined there. And as we get to examples that relate to infrastructure, that becomes critically important, because kind of in the example here, the one over on the right here, where we're showing VLANs, which is kind of a mechanism of defining segmentation in a network infrastructure, I could have thousands of these with hundreds of thousands of different parameters there. If the way I ask the question is different, or if the response I get is different based on whether it's VLAN 1 or VLAN 10, the ability to program against that becomes immensely more complex. So having that common data structure makes it more consistent and easier to be able to code and to be able to get information from an object, as well as to provide out information to that object. But back to the left-hand side of this diagram, I'm kind of showing more of a real world type of, or kind of a more general type of scenario for this. So as I mentioned, in JSON, I have a key and then I have an attribute. So up at the top, the key is meeting name. And right now the meeting is JD10. My next meeting is internal staff meeting. My meeting after that is partner XYZ meeting. But the structure that I would use for all of the attributes that would below that would be the same, but what changes is that attribute for that. So if I want to code something that says, go ahead and look at my calendar, I can look, I always know that the meeting name is going to be in that field, and then I can make, I can do queries, and I can understand what the difference is between all of those, as long as those key and attributes are consistently defined. And those keys and attributes can be, again, both nested as well as I can have multiple inside of there. So the blue section there is kind of more of, these might be people who are part of that above needing. So first name and last name. So, the first object there is my first name and my last name. The second object, or the second participant in there, that's Antoinette, and her first name and her last name. So as we would have more people that were in here, I didn't have the real estate in this diagram, but we could talk about Errol. We could talk about others that were part of this meeting, and it would all follow that same structure. That is critically important to the concept of infrastructure automation, but as well as just traditional data science and data storage formatting. But being able to apply that consistently is what gives us the ability to scale and the ability to consistently operate as we look to digitize and automate and program against an enterprise infrastructure. So the next step on our journey map would be discovering, and what can I do to kind of understand what's inside of there. And one of the mechanisms we have for this is what we call API documents or API docs. And for every product that Cisco produces, and this is consistent for much of the industry as well as for ancillary industries, is the idea that if I have an API, I have to document what's inside of here. And you can see the diagram or the image on the right that's put in what is known as Swagger format for that. And then it's what it is. And then you have kind of an understanding of the hierarchical display of the tree, the supported functions and methods. So the methods are the different colors you see over there. I mentioned before that, kind of that request response could also be a command and response. So a post is I'm pushing something to the device. So I'm creating an object, I'm assigning something, or I could have a get, which is more of an ask. So I'm asking you to send me the site health. I'm asking you to tell me the members that are associated with that site. And another type of write type of request or a command would be a delete. So I'm no longer using the site. So this would describe the function that you'd use to do a delete, or a put is an update. So, and this is important to understand with APIs. There are the two most common commands that you would send are what are known as a post or a put. And functionally, I'm telling you to do something, but the difference between a post and a put is a post is I'm going to create a new object, where a put is I'm going to modify an existing object. So, and this would all be described in the API documents for it, but that's a key concept to remember, that as I'm doing configuration, the difference between a post and a put, we all make that mistake where I'm trying to, I'm doing a post to update something, and it's going to come back and tell me, nope, doesn't work, give you error messages, and you spend a bit of time troubleshooting that. But that's kind of part of the process for that. And kind of a deeper view of what that documentation looks like. So you can kind of see on the far left of this, there's the subset of that, and then in the middle section, that's really the textual component of describing exactly what that post command looks like. The types of things that up at the top, kind of the text in green, that's showing the thing that's common, and then the item that's in white, that's showing you what's the variable that you would use in order to get at that. And you can see things that are related to the path, the body, how the header gets formatted, and further down in that document, you would see things like the response code. But what's also cool about this, and it varies by platform and it varies by vendor, but there's the concept of having, of the documentation being what I refer to as live documentation. So the far right of this screen is showing a simulator for that. So I'm not just looking at the API, but I can simulate the commands or the requests that it would be making to that in the format that it expects, and seeing exactly what that response is for. Now, it's not going to show me live traffic, but it's going to give me an emulated experience to understand exactly how I would interface with that. And we have that both in the documentation for some platforms, and some of our platforms and equipment, the simulator is actually running live on the device. So all I need is that device in my laptop to connect to it, and I can simulate against that and kind of read the documentation and learn against by leveraging that simulator before I ever write anything to it that would have the potential of modifying a configuration on a device. So very important in the discovery, or very beneficial in the discovery phase of kind of learning how to interface with that API. There are multiple mechanisms that you can use for it, both reading as well as, kind of that simulated experience. Another common tool for that is a tool that's known as Postman, and it's a constrained web interface. But what that is, it's constrained, and that it's not about going out to Google and kind of looking for whatever, but it's leveraging the same concept. But it's constrained to the idea of APIs towards a specific object, and this is a virtualized environment where instead of going into a command interpreter and starting to write code, you can visually go through and you can target the APIs that you're going after. You can type in the commands or the variables that you want to put against it, and it's going to send those commands to that device, and it's going to show you the response that comes back to it. So before you write a single line of code, you can just go into Postman, point it at the device or the system that you're going after, and start to write requests directly in that visual interface and see exactly what the responses are. So this is very beneficial both from a learning and discovering phase of kind of making sure you understand exactly how to go after it before you start spending a bunch of time writing code, as well as this is a fantastic troubleshooting tool. So if things aren't coming back exactly the way that you're expecting, you can leverage Postman and you can see exactly what the responses were. You can see exactly what your query was, and that's a very common way of troubleshooting both from the development phase as well as post development if you run into any issues. And you can kind of see it. I'm not sure how well the mouse is showing here, but I mentioned the concept of gets and pushes and puts and deletes and such. Up here in Postman, you can set that. So again, the common thing is you can set whether I'm doing a get or a post or a put or a push or a ghost or a delete directly from this interface. So you can see exactly what happens if I'm trying to do a post to an existing event, or if I'm trying to do a put to a non-existing object. But another thing to look out for is that's kind of where you run into that problem leveraging Postman. So the next step on the journey map of after we've started to do some learning and we've done some discovery is to actually get into coding. And coding from a network infrastructure or from an enterprise infrastructure perspective, there are several languages, just as though there are human languages to communicate with. There are even more languages for writing in computer code. But when we talk about enterprise automation, the most common language, at least as of today, is Python. And from a Cisco perspective, and I'm quoting Hank Preston, who's one of our Devnet guys who does a lot of public speaking and kind of does a lot of education in this space. We believe and I'll kind of paraphrase this quote to be less Cisco specific, but we believe that from an enterprise automation perspective, understanding Python is going to be critical to your success, whether you're doing traditional network engineering, whether you're doing security, whether you're doing cloud ops or cloud computing or application development. As you're in that enterprise infrastructure realm, Python is very important to your success there. And Python, I'm not a fan of snakes. Why do I need to care about Python? One, it's very prevalent, and there's no such thing as an industry standard software language. But from a functional perspective, today Python is that de facto standard. And some of the reasons for it is it's plain language readable, at least for the most part. There's always idiosyncrasies and syntax that kind of get in the way of plain language, but you can almost read it in the way that you think, instead of trying to wrap coding syntax and trying to wrap your mind around that. So it's easy from that perspective. It's flexible in that it can both be object-oriented or traditionally structured code, and it's supported on multiple platforms. We have Python that runs natively on many Cisco devices, so you can directly leverage Python directly against some network infrastructure that might be in your wiring closets. And there are many standard and open source libraries for that exist for it. So standard libraries that support things like time and calendaring and accessing files, as well as some open source libraries that, in this case, you can see in the blue comment there, we're importing a library called CLI, which means command line interface, which is the the traditional textual method of interfacing with a Cisco device. And here, what we're saying in that last line in the blue there is I want to print, leveraging the CLI library, I want to execute, or I want to run a show version. And show version is kind of the one of the most generic commands that basically says, show me about yourself. And this is the mechanism that you would use to run that simple command through Python. And how to access Python, as I mentioned, it's available on many platforms. If you're a Mac user, Python's already there. If you're a Linux user, Python's already there. If you're a Windows user, it's just a software install away, and it's a very simple mechanism to do so. And if you want to determine that it's there already, Python's -c in quote print hello world, and if that works, you've written your first line of Python. That's as simple as the hello world example is for Python. So you can use that both by just directly interfacing from a command line on your device, but a more scalable, particularly as you start to do shared coding, or to start to share your code or collaborate as you're writing code, as then you want to start to do that in what's known as an IDE, or an integrated development environment. And one of the most common ones for that these days is a tool called VS Code. So VS stands for Visual Studio. Going back 20, 30 years, Microsoft's primary coding development tools were known as Visual Studio. They have released an open source, so VS Code is completely free. It runs on multiple platforms. I'm a Mac user. I use Microsoft VS Code. That's the IDE that I use. It supports multiple languages. So if I'm doing some IoT work on Arduinos or on Raspberry Pis, I can kind of develop inside of there. If I'm writing Python code that I want to use to interface with network infrastructure, I do that there. And there's even interpreters in there that if I'm writing particular Excel formulas, there's plugins for that. So I can use that same development environment. I can share that out. I can put that into tools, and I can do revision control all through that one IDE. So highly recommend that if you're not using those, and I didn't mention that earlier, but things like Postman, just Google Postman, you can download that. VS Code, you can download that. And as you're starting to go down this world, that's a great place those are great tools that are freely available to you to start with. So as we've built our codes, or as we started to build code, generally we start with very simple examples, but as we want to scale that out, both to the complexity of what I'm writing, as well as to scale that out to multiple individuals, the concept of version control becomes very important. You've likely seen this of whether you're doing a collaborative project as a presentation or a document or some sort of report. Multiple people writing against that, you run into the challenge of who's got the latest version and who overwrote my changes and those sort of things. So that problem very much does and has always existed with software coding. And kind of some of the key questions of how do I make incremental changes and share that with others? How do I go back to yesterday, last week, last year? What changed between version X and version Y? Who made those changes? How do I know what they are? And as I've had multiple people work together on a particular project, how do I reconcile and merge all those changes together? Today, the most common tool for that is what's known as Git, and you may have heard of either Git or GitHub. Very much the same type of tool, but a little bit different in the way they're deployed. If it's just a single user and I'm doing revision control, or if I'm kind of doing an enclosed system, I can get away with the open source tool of Git. I can run it freely available on multiple types of platforms. But as I look to start to collaborate with users or collaborate across multiple devices, then GitHub adds that collaborative cloud-enabled type of scenario to it. And you can both run GitHub in a public cloud, or you can run a GitHub version in your own enterprise, so you don't have to worry about exposing things to the public if you don't need to. But then the idea, basically, if it's just one user, I can get away with Git. If I'm trying to collaborate or share that code, using GitHub is really the best approach. The best approach for that. And there are other alternatives. There's GitHub, there's GitLab. They're all similar in that same concept. But again, am I doing this with one user, or am I doing it in a collaborative function? And the workflow for this, kind of looks, if I'm leveraging GitHub, the first thing that I do is I've got code that's in there. I don't want to, the way that I basically check that out is I clone that. So I'm going to take a copy of that and I can, I can start to work with that. I can play around with it. I can learn from it. I can, try to make the next branch from it, but I do that without ever touching the original source. So hundreds, thousands of people can clone that repository, but that original stays always the same. As I want to start to modify what's there, I can then check that out. I can write my code against it. Then I can commit that to it. And I have that history of, this was version 1, and then I'm going to do a commit. And now I've got version 1.1. So that now becomes the primary code that's there, the most current code. But I always have that history to know to go back that, 3 months later, we find that there's a problem with it. We can always go back. We know exactly what was changed from one version to the next. We even know who it was changed. So, not to berate them, but to at least, what did we miss here? What is not there? So we can kind of fix what's inside of that. But we have the ability to always keep that revision history, as well as to be able to create new branches to add new features and capabilities, leveraging a workflow and a revision control system like GitHub. So as I've scaled that up, now I want to look to expand that. And what can I do with it as I have some of those code capabilities? And now I want to talk about some open source kind of collaborative tools that are available that leverage all of the concepts that I talked about earlier, but do it in a pseudo package type of format, going after a specific outcome. So if you're focused on enterprise infrastructure, that's networking infrastructure, that's server infrastructure, that's databases, that's telephony systems, everything that we use in an IT infrastructure space. All of those things generate logs. All of those things see issues. How do I monitor the health of that? Over the history, every one of those systems kind of uses similar concepts. They may write to a similar application, but they may write things in a different format. And I kind of mentioned dates earlier. Do I when I'm doing dating and timestamping, do I lead with the month? Do I lead with the year? Do I lead with the day? How many digits of resolution do I use with time? How many digits of resolution do I use with year? Again, there's no standard for that. So as I'm combining logs from multiple objects, coming up with a mechanism of standardizing that to be able to then look across the entire infrastructure and visualize that. That's the entire purpose of what's known as the ELK stack. And it's ELK because it's kind of Elasticsearch, Logstash, and Kibana. And it's those three tools together that gives me the ability to log processing. So Logstash is used to kind of normalize the type of data that's coming from multiple systems, and be able to put a common taxonomy across that. So again, if someone's leading with the month versus the day, I can write a rule in Logstash that make all of those consistent. Then I put that into Elasticsearch, which becomes a database that I use that allows me to use free text against that. I'm not using a lot of SQL type of queries to go against it, and I can look at different data types, but it's easier to plain language search against that for things that logs. It's a very easy mechanism a very scalable mechanism to support that. And then to actually see what's in those logs, I can use a tool like Kibana to actually visualize what's inside of there and kind of a graphical look of what that is. So on the left-hand side, multiple different devices that are sending their logs, and then I can go and collect and transform those across any type of mechanism that you're using to send it, whether it's SNMP, whether it's syslog, whether it's doing a webhook type of push to be able to send its information. And then as I've got that collected and normalized transformed data, I then put that into Elasticsearch as a database, and then I can use Kibana to actually write my queries against it and show exactly what's going on with that. That makes it easier for me to operate and automate the types of trouble response for an enterprise infrastructure. A similar type of scenario is what's done in the TIG stack. So ELK is about logging and TIG is about performance monitoring. So think of that about graphing or in kind of real time, as well as historical trending of what actual performance looks like. And that uses a similar concept in that it does a normalization of the data that's being collected. It stores that in a database and then uses a tool to do the visualization. And that makes it very simple to do logging capabilities here. So I can see from an infrastructure device, I can take multiple types of telemetry coming in through multiple different systems as well as different protocols. I then, I normalize that through Telegraph and I put that into InfluxDB, which is, it's known as a time series database. So logging performance statistics, those are never things that you're not going to go back in 3 months and update that because for whatever reason. So that database is optimized to be written very fast and read from very fast because it doesn't have to worry about journaling or doing changes or deletes or any of those things. It's a historical real-time database. And then Grafana becomes a graphical tool that you can use to measure this. And this is kind of a graph that's showing what it looks like for a cloud-hosted application of looking at what the traffic looks like, what my daily averages are. But it's looking at this from not just the perspective of an application or a single element. I can take data, I can graph together data from multiple different sources and put together a real world scenario of it. So it's not, well, the network's fine. It's not the service, it's not the server that's fine. It's not the app that's fine. I can write a dashboard that's showing what the actual business impact of the entire infrastructure is and show what that means to my business. And the beauty of things like the TIG stack is I can monitor things that are outside of what I would call the IT realm. So let's say if I'm doing this in the factory side of in a factory type of deployment or a financial services type of deployment, I can look at kind of what the welding machines are doing, what the robotic assembly machines are doing, or I can look at what the performance statistics or the environmental status of the ATM machine is. So I can see what my network infrastructure looks like, and I can look at the application. So the application or the end use. So I can use this graphing tool from an automated infrastructure to show what the true business capability of the overall operation is. So then I'm presenting to my management not just what the IT world looks like, but what the actual business looks like. So then as we've done those deployments, or as we've built those capabilities out of doing the deployments, sorry, I'm on deploying now. There's a box over, so I can't see exactly where I'm at. So I've done the expansion, I've written my applications, now I need to deploy those. And applications can be deployed in multiple types of scenarios. So on the left-hand side, kind of a traditional, over the last 15, 20 years of kind of a virtual machine type of world where I have a bare metal server asset. I put a hypervisor on top of it and I run multiple virtual machines that are with multiple operating systems. And then I have applications that are segmented at that operating system or application level. In the last 10 years or so, application development has moved away from the idea of a monolithic, this is everything that the application needs, to more of a requirements or a discrete requirements scenario defined as microservices. So instead of having the enterprise ERP system, which contains the database, it contains all the application servers, it contains all the connectors. Each one of those objects can be defined as a specific microservice that is run as a specific container that makes it easier and more scalable for those types of solutions, and allows for the idea that those resources can be located either closer to where the end user is or more centralized depending on the function. And from a microservice perspective, there are many common mechanisms to deploy that. But in a microservice container type of scenario, Docker is kind of the most common mechanism for it. And then Kubernetes, which is basically a management component for Docker. But also in the blue circle there, we have what we call IOX, which is a containerization system that works directly on top of Cisco hardware. This is very common in the Internet of Things space, where I could have a device that's on a remote oil field, and I can have code that's running directly on the router that's providing connectivity for those devices, and I can move some of those microservices directly to that end location to enable more resilient processing, the ability to collect data when the network goes down. I'm still running a local copy of that, which can then send that information up. That's a concept of microservices that didn't exist really on the left-hand side of this, and that I needed a full server infrastructure to support that. That's one of the benefits of a microservice type of scenario. And the way that looks for a containerization is it's somewhat similar to what we saw on this slide here, where I start with bare metal, but then I have a single operating system. One of the complaints associated with virtualization is, sure, I'm using less hardware, but every virtual machine I have is another operating system instance that I have to maintain. It's another operating system instance that I have to license. Containerization removes that component, and that I'm containering on top of the OS. So I can use one server instance, one operating system instance, and then I can set virtual containers on top of that, which minimize my expense, my management footprint, and the operational cost of doing so. And then what I'm not showing in the slide here, but all of these containers, so everything from the light blue up, that's a container that can live both on-prem, so whether that's in a traditional data center, whether that lives at the edge in that IoT use case that I'm talking about, or that container can live in any one or multiple clouds. So that gives me the ability to, as I'm defining and designing what my application environment looks like, I can pick and place these containers to live where it makes the most sense, both from an operational reliability and a cost mechanism. I have that flexibility as I move to a containerized type of environment. But those containers basically they're simulating, or they're isolating the components of the operating system, so the application has all the resources it needs, but only the resources it needs. So I never have to worry about, even though the app 1 and app 2 are running on the same physical hardware on the same server, they don't have the ability to write to the same shared or common or traditionally shared or common types of file systems or spaces. So whether that's logs in Etsy, whether that's binaries or executables that are running in bin, it gives me the ability to isolate those. So it makes it so that my applications are more repeatable, my dependencies are specific to the application itself, and it makes it so that application can boot much faster, because I'm not waiting for the hardware or the OS to boot. I'm only waiting for that virtualized container instance to boot up. So in that journey map, we went through all 7 steps here of learning, discovering, coding, scaling, expanding, and deploying and automating, and we kind of talked about some of the tools, the concepts. I've given you some examples of where you can start to find some of those tools that are there. But I also want to talk about what that looks like and kind of go back to that DevOps concept there. And there's this concept known as CICD, continuous integration, continuous deployment. And what that's about is, instead of, so in programming, there's many methodologies, but the 2 common, most key are what's known as waterfall, and then there's agile. So waterfall is I do one thing and then move to the other, whereas agile, I'm defining very small sprints and I'm completing the components of those and then moving on to the next sprint. So at the end of the day, I may get to the end goal at the same time, but because I'm releasing smaller improvements or smaller changes in a faster rate, I'm continuously doing that integration and deployment. So it makes it so that I'm getting more rapidity into what I'm doing, and I'm also getting faster feedback on the changes that I made. Those same concepts apply to networking deployment. So instead of or infrastructure deployment. So instead of having to build out an entire change and look for a 36-hour change window to deploy a new configuration update, I can do that in more small steps, where I'm continuously identifying that, okay, there's an issue here. Let me deploy that discrete change into multiple locations. I've got all the monitoring. I've got the full software dev or DevOps mindset attached to it. So I know the limit of my scope. I have testing built in. I have my documentation. I've done all that integration. that CICD concept is very different from what it was 20 years ago when I was operating networks. This makes it much easier and much faster to deploy changes and to increase the value and the business value of the infrastructure that you're operating. Automation tools that leverage this concept. So I spoke earlier about the idea of configuration management, and there's a couple, very common tools in here. So Puppet, Chef, Ansible, those are all about configuration management, of making sure that I've got consistency of the type of configurations that I've got there. And then there's a relatively newer player, Terraform, which is about provisioning. So it includes the concept of configuration management, but it also ties that into a provisioning angle. And what that means is configuration management is great at saying, this is my configuration for my network switches, for my routers, for my firewalls. Here's my configurations for my virtual environments, for my cloud deployments. Terraform ties all those together and kind of looks at it as an outcome and says that I'm trying to get to this capability, which requires this network change, which requires this firewall rule set. It requires this container to be moved to this particular location, and moves that into a provisioning tool that allows you to automate and scale out the deployment of the various components and not just look at it from a configuration management perspective. So these are all things that you can that are great places to start. They're a bit more advanced, but these are very important tools that as you migrate your career towards infrastructure automation, knowing the capabilities of all of these has its place and is very important. From a Cisco perspective, we also have automation tools that we kind of look at this in multiple areas. So enterprise networking would be our DNA center. Site-to-site connectivity would be our SD-WAN capabilities. And then for both data center and cloud operations, we have what we call ACI, or application controlled, application contextual. Errol, fix me on the acronyms for ACI, but we can get back to that. So as we go through there, I want to kind of give you a taste of what it is that you can develop and what's there. And we want you to view this as an evolution. So in Devnet, we talk about the concept of walk, run, fly. You've likely heard the analogy that Rome wasn't built in a day. The same thing applies to software programmability. So we encourage you to divide that up in the concept of walk, run, fly, where walk is about, kind of getting visibility and insights into your network. Run is how do I activate network and security policies? How do I start to, so walk is kind of read, write is kind of, or run is kind of start to write and make changes, and fly is how do I tie that together into that full DevOps mindset and workflow. For inspiration for that, we have what we call our Devnet Code Exchange. You can find that at developer.cisco.com/code exchange. And in there, this is where we want you to not reinvent the wheel for each individual as you start on your journey. We want you to stand on the shoulders of giants. People have already solved part of this problem for you, and this code is freely available for you in the Code Exchange to start with that. And because it's available, you can take it, you can use it straight away, or maybe you modify it and tweak it slightly to your specific use case, but you're not reinventing every wheel. Someone has already started part of that process. You can leverage what they have built and start to add on to it. And then you can recontribute that back to the community that, thank you for this version of code. I've modified it to do this because it solves this particular problem. And then you're giving that back to the community from what you started to grow. Next steps that you can take there, starting with your learning, developer.cisco.com/start now. That's our start now concept. That's free introductory learning content that's available for all Cisco platforms for generic coding and software principles. It's a great place to be able to start your journey. And we divide this content up, or we build this up in very bite-sized chunks of content. So these are not 30-hour classes. These are as short as 5 to as long as 30-minute type of various scenarios that we divide up for that. We did that very intentionally. That hey, you're in a meeting and the meeting ends 15 minutes early. What do I do? Hey, let me go to the Devnet Start Now and let me do a lab on a particular concept here, just so it's very consumable and it's very easy, and we target you to exactly the outcome that you're looking towards. So if I'm trying to figure out a very specific problem, we have samples and we have learning modules that take you directly to that. And then as you want to go beyond that, we also have structured learning components. So we've recently announced that we'll be launching soon what we call Cisco U. And the idea is that, that's learning targeted towards you. So it's following that Devnet model of kind of more targeted towards where you are from a learning perspective, but this is for all Cisco technologies. And we're pulling in non-Cisco capabilities to this as well. So as we talk about some of these hybrid cloud environments where I'm using Cisco technology, but I'm using storage from a particular provider, I'm putting this into a cloud hosted instance for part of the workflow. We'll have content in there for that. And it's announced yet, but it's not going to be released until early in 2023. But you can go ahead and register for that and start to get early access at u.cisco.com. And with that, that's what I wanted to cover in this presentation. So I'll hand it back to Antoinette to see if there's any comments or questions. And if not, I thank you for all of your time and attention.
Thank you so much, Chuck. I truly appreciate that presentation. It was very wonderful. I'm a little bit out of my league in regards to development, but I definitely learned a lot from this. Lachlan, do we have any questions in the YouTube chat at all?
Well, the one question I had was around certifications, Chuck. What's the best certification? I know Cisco has a CCIE and a CCNA track. Which one's best suit for DevOps or automation, that kind of thing?
Yes, absolutely. So from a Cisco certification perspective, you mentioned CCIE. That's been the gold standard in the industry for many years. I'll kind of pat myself. I've got that certification, but you also see up there I also have the Devnet certs. And what we've done with that, we released the Devnet certifications in February of 2020, right before the pandemic. And when we did that, we looked at our entire certification portfolio. And we made adjustments to every certification that's there. So we have Devnet certifications that cover all of the context that I was talking about. So a great place to start is with the Devnet Associate that covers all of the software programmability fundamentals that I spoke to in this presentation. And then we have the specialist component, which is software programmability towards a specific area. One of my prior lives was working in IoT, so I actually have the Devnet certification for IoT that talks about how to do software programmability for that particular scenario. And then we have the Devnet Professional. And just this year, we released the Devnet Expert. So we have the CCIE, which focuses on network infrastructure, software programmability towards a specific area. One of my prior lives was working in. We have the Devnet certification for IoT that talks about how to do software programmability for that particular scenario. And then we have the Devnet Professional. Yeah, sorry, I was getting a lot of repeat there, so I'm not sure if someone's got an open mic or if we had
It's muted now. It's muted, Chuck.
Okay. So what I was saying is we just this year released the Devnet Expert component of it. So now from both a infrastructure, a traditional hardware or engineering cert, we have the associate, the specialist, the professional, and the expert, and now we match that on the Devnet side. But as I was saying, we modified all of our certifications. So if I'm doing a traditional infrastructure certification, that's now going to be 80 to 85% focused on the core network component of it. So if it's CCNA, it's going to be 80 to 85% focused on traditional networking, but that remaining 15 to 20% is going to be on the basics of software fundamentals that are part of this. So that even if I have a networking centric type of certification, I'm still going to be exposed and tested on the software component of it. And we did that intentionally to make sure that both of those camps have a common language and a common base point to start with to collaborate and communicate with each other. And it's the same with the Devnet component of it. So if I take the Devnet Associate, that's 15 to 20% are going to be on core network fundamentals, not just on software programmability. And we think that's important because if you're getting a Cisco certification, it's about how do I leverage software for infrastructure automation. So we want to make sure that a Devnet certified individual understands software, but also understands how to apply that to an infrastructure world.
So thank you, Chuck. There's another follow-up question in regards to certs. So the question is, along with certs, what else would you recommend to get a job?
So certs are a great mechanism to use to establish that you have the base core knowledge. When I'm hiring, I'm looking for four primary things. Do you have the technical capabilities, which you can demonstrate as a cert? Do you have the experience, which you can only get by having experience? And I understand that's kind of that, well, how do I get experience before I start? But other areas that I look for that is, do you have, what is your mindset? What is your character look like as far as, okay, yeah, I know I don't have this, but I've demonstrated I have this aptitude. And what does it look like from a culture for you kind of fitting into the team? So I'm not hiring now, but if I am, I would look for someone who has certifications, and I would look for someone that is demonstrating a character and aptitude that says they are willing to, and by having that cert, they've demonstrated that they have the ability to learn, and that you have that cultural fit that says, I want to fit inside of that team. And if you have those, I can train you to get the experience. So the things I would focus on if you're early in career is get the certs, make sure that your character is one to be open to exploring new things, and that you're demonstrating a culture of working in a teaming environment. And then you should be able to find opportunities where you can start to gain that experience that will then help you move into higher levels.
Thank you. And the follow-up question to that is, what is the need in the market today for anyone that's in development?
So the need is, I guess I will say, immense. So if I'm looking at it from a traditional Cisco or infrastructure perspective, the world is moving towards automation and programmability. So the program that I used to run inside of Devnet for doing our partners, that was based on customer demand of, we need to find individuals that have these capabilities. I don't have this skill set in-house, so I want to find partners that have the ability to do this automation and programmability as they were building up their internal capabilities for that. So the demand is very much there, and it's there not just inside of Cisco. So there are demands for this coming from all the major cloud providers. There are demands from this coming from all of the other infrastructure players, as well as some of the ancillary components. So whether I'm looking at storage, whether I'm looking at security, whether I'm looking at applications, those are all things that are all of those, discrete spaces have a certification component of that, to help an employer to understand whether or not a candidate has the capability. But I think it's equally, and I'd say sometimes even more important as a measuring stick for a candidate to know, I think I know this, but do I have some sort of external validation that shows? And then both, I get that external validation, and that's something I can put on a resume and lead with an interview that says, yes, I have this cloud certification. Yes, I have this DevNet certification. I know how to solve the types of problems that your organization is looking to address.
Thank you.
So one last question, Antoinette, Chuck. It's around the community as well. Is there a community where people can participate, like students or professionals, ask questions, share best practices, that kind of thing?
There is. So as I mentioned, the Devnet community. So I mentioned the community, but I never mentioned how you actually access it. So if you go to developer.cisco.com, that is the Devnet portal. From there, you can register. You can register that through multiple mechanisms: an email address, a social media account, a Cisco account. All of those will allow you to register for Devnet. That will give you access to all of the learning tools and the labs and the things that I talked about there. But then that also exposes you to the community. Other mechanisms that we have for the community, there are community forums. There's the Devnet Twitter feed. There's from Cisco, we use WebEx. We have WebEx Teams. There are publicly available rooms that are there that we have members of the community that will ask questions and collaborate with each other. So there are multiple mechanisms to get that, but the starting point is to register and enable an account at developer.cisco.com.
Lachlan, is those are the questions on your end? I have no more follow-up questions.
I think I'm good in my end. Yeah, we're over time, so.
Chuck, thank you so much for sharing with us today. This was a vast, lot of knowledge that we took in today, and thank you for sharing the resources that we could definitely share with the diaspora and how they could transition into this area. So I do truly appreciate it, and we will definitely be following up with you.
My pleasure. Thank you so much. I appreciate the opportunity to speak to your team.
Thank you. Thank you, everyone.
Thank you.